All right, here we go with problem 9.5.41T. So this is another one of those. They want us to find the type 2 error or the beta. Um, and again, it's pretty complex. There's a bunch of moving parts, so I'll just kind of jump into it. First, we'll answer these questions. A type 1 error can occur when a researcher concludes the average hours of sleep changed, but the average hours of sleep did not change. And a type 2 error is when the researcher concludes that the average hours of sleep did not change, when in fact they actually did change. So that's sort of the definition of type 1 and type 2 error. So now we'll get into how we figure out the actual type 2 error. So like every other problem, we have to start with what we know and what it gives to us. So we'll start with the expected mean. The expected mean is given to us right here it says the average person age 15 and older gets 503 hours of sleep per night. So that's what we think it is. To test this average, if the average has changed, recently a random sample of 64 people, so N, our sample size is 64. Age 15 and older was selected, the number of minutes they slept was recorded. Assume the standard deviation of hours of sleep is 57 minutes. So this isn't telling us that that was the sample standard deviation. It's saying assume that that is the standard deviation. So we're going to call this the population standard deviation. Is 57 minutes. Using an alpha of 0.05. Complete the parts A through C below. So the first thing it says is calculate the probability of a type 2 error given the actual average hours of sleep of 509 minutes. So I'm just going to call this the actual average was 509. That's our sample, right, that we took. All right, so to do this, we're going to have to use these two formulas. This one's called the critical mean, and then this is our z value for each point of the critical mean. So this is a two-tailed test, meaning this isn't like we think it's higher, we're testing for that, or we think it's lower, we're testing for that. This is we're testing to see if it changed. So our null hypothesis would be that it equals 503 minutes, and our alternative hypothesis is that it does not equal 503 minutes. So the first thing we need to find to use these formulas is our critical z. And then to do that, remember we always want to use the positive value of critical z for this. So I'm just going to do this, say that this is the absolute value of norm.s.inv, where the probability is our alpha divided by 2. So this is also called the z of alpha divided by 2. So our critical z is 1.96 plus or minus that. So now we're going to find our critical mean using this formula right here. And because this is a two-tailed test, we have to do plus and minus. So we're going to have an upper and a lower critical mean. So I'm just going to call this critical mean upper and critical mean lower. And I'm just going to use the formula. So the formula is that this equals the expected mean plus the critical z times, in fact, I'm going to put this in parentheses. So our expected mean plus the critical z times the population standard deviation over the square root of n. So that would be our critical mean upper. Our critical mean lower is just going to be our expected mean minus our critical z times our population standard deviation divided by the square root of n. There's our critical mean lower, okay? Next, we're gonna use our critical mean that we've just calculated to find our z value of the upper point and the lower point. So I'm just gonna call this, z value upper and z value lower. So our z value upper is going to equal, so we're using this formula right here, okay? So that's going to equal our critical mean upper minus our actual average divided by the population standard deviation over the square root of n. So there's the z value of our upper point, and then our z value of our lower point using the same formula. But we're going to use the critical mean of the lower point minus, I'm going to put this in parentheses, sorry. Critical mean of the lower point minus the actual average divided by population standard deviation over the square root of n. So there's the z value of our lower point. All right, so to find the beta, what we need is the probability of getting a result that is between these two z values. So what I have to do is find the probability of the upper, then the probability of the lower, and subtract the two, and that's going to give me the beta. So I'm just going to call this the probability of the upper. I'm going to call it the P of u, and then we'll need the probability of the lower. So the probability, to find the probability, we're just going to use norm.s.dist, and then we're going to use the z value of the upper, comma true. That tells us the probability of finding a point 1.12 standard deviations to the right of the mean and less. We're going to do the same thing to find the probability of the lower. So equals norm.s.dist. And use the z value of the lower, comma true. That tells us the probability of finding a point of less than negative 2.8. So our beta then will be the difference, or the probability of being in between those 2 points. So there's our beta, 0.866. And we hope we got it right, and we did. Then the second part, or the third part, is actually going to be like do the same thing, but for an actual average hours of 496. So I'm just gonna, I have my formula, everything's in there. I've created my own calculator, so I'm just gonna put in 496. And it recalculates everything for me, and my new beta is 0.834. And that's it. Hopefully that was helpful. Again, don't be afraid to reach out if you need help again.